Yes, right. Just ping me. Yes. Okay. Okay. So, right, we were discussing about digital systems. So, digital systems, you know, what is the advantage of going to digital systems instead of analog systems? So, analog systems are more affected with noise, and it is very much impossible. It is very difficult to retrieve the signal back once if it is transmitted at the receiver end. There will be loss in the information. That's why we will not go for the analog signals, analog systems. So digital systems, so only two, what is that, only two values will, two logic levels will be there in the digital systems. So digital systems are more easy, for digital systems it is more easy to retrieve the data back. Okay. So, and also one more important point is digital systems, they consume very much less amount of power compared to the analog systems. And in digital systems are very much easier to design than analog systems. Okay, so all these things are the examples. And for a digital signal, we have greater accuracy, only two logic levels, logic 1 and logic 0. And we have seen, yesterday we were discussing about the binary number representation. So decimal numbers are there, decimal numbers are ranging from 0 to 9, 0, 1, 2, 3, up till 9 are the decimal numbers. And the base is 10 for decimal numbers. And so weight can be given as base power, position is nothing but the weight, magnitude is given as the sum of the digit, all these digits into weight is nothing but sum magnitude. Okay, uh, if you are summing up all these things, you will get the magnitude of that particular number. Okay, so what else we have seen? Next, octal number system, base is 8. Okay, base is 8 for octal number system. So next, hexadecimal, yes, hexadecimal number system. Hexadecimal number system, the base is 16. So 0 to F till 9 as usual, and from after 9 A to F. Okay, these are the values. A is representing 10, and similarly F is representing the value 15. Okay, so all these things which we have discussed yesterday. Binary number system, base is 2. Okay, only two digits, 0 and 1. Okay, weight, magnitude. And group of four bits is called as nibble. Okay, 8 bits is called as byte. This is one important thing. And these are the what powers of 2 for the binary numbers. And we have seen the decimal addition and addition, subtraction. Okay, this is number based conversion, right? We have seen the conversion also. So conversion and all these things, just let us skip. Binary to octal conversion, binary to hexadecimal, octal to hexadecimal. All these things we have seen. Now we will see the conversion cheppana nenu. Conversion cheppaledu. Okay, I did not. We have not seen this conversion, right? Binary to octal conversion. I think where we have stopped yesterday. Yes, we have stopped here. So we will see the number conversions. Okay, let's look at this conversions. Octal, binary to octal conversion. So, okay, let's see here. This is not working. Okay, binary to octal conversion. So, what we have to do is each group of 3 bits represents an octal digit. Okay, each group of letters. Suppose if we are taking this 1 0 0 1 0, this is group of 3 bits. 1 1 0 group of 3 bits. 0 1 0 group of 3 bits. Okay, so 0 1 0 it is indicating what 0 1 0 means 1 2 and 4. What is this? It is representing 2. 1 1 0 is representing 1 2 4. What is this? 4 plus 2 is 6. Okay. And 0 1 0. Okay. 1 2 4. Okay. So what is the 2 here? It is representing 2. Okay. So 2 6 2. This way we represent an octal number. So normally 8 is an integer. So 8 is an integer. If you want to write this integer in the form of binary, how do you write? How do you write 1, 2, 4, 8? So like this 1, 0, 0, 0. Now what we have to do is we need to convert into octal, right? We need to convert into octal number. So what you have to do? So you have to make 3 bits as a group. Okay, you have to make 3 bits as a group. So here nothing is there. What you need to do, you can append zeros here. Okay, we'll see one example here. This way you have to convert octal number into binary. So octal, see 0 is 0 0 0, 1 is nothing but octal 1 is 0 0 1. Similarly, octal 6 is 1 0 0. This is the position 1, 2 and 4. Okay, 6 is 1 1 0 and 7 is triple 1 is representing triple 1 is representing 7 4 2 1. Okay, so now next thing is binary to hexadecimal conversion. What you will do? So you will make a group of 4 bits. Okay, you will make a group of 4 bits. Let us suppose what is this? This is what if this is the actually this is one fraction. It is given 10110.01. Okay, so this is a fraction actually. Whatever is there after this 0.01, okay, it is only two digits, right? Only 2 digits. So we need to append the zeros at the right. Okay, at the right. If it is after this decimal point, so you should append the zeros after the you should after this particular digits. Okay. Next, here you are making group of 4, and this is group of 4 after appending these 2 zeros, and 1 bit is left. So you need to make it as a group of 4. What you need to append? You need to append with more 3 zeros. Okay. So now what is the number? This is representing 1. This is representing 6, and this is representing 4. Okay. 1, 2, 4, 8. Okay. Like that you will see. So this 0, 1, 0, 0, 0, 1, 0, 0 is representing 4. You can see here. So this way you will convert a binary number into hexadecimal number. Okay. So next one, what we will see is octal to hexadecimal conversion. Octal to hexadecimal conversion లో మీరు ఏం చేస్తారు? Octal to hexadecimal conversion 26.2 అనేది ఇచ్చారు ఇక్కడ. ఓకే, 26.2 అనేది ఇచ్చారు. యాక్చువల్లీ వాట్ ఈస్ దిస్ 2? This 2 okay, so what is this? 26.2 is given. What is this 2 actually? 2, what is the 1 0? Okay, so octal representation is 0 1 0. Octal representation of 6 is, what is octal representation of 6? 110. Octal representation of 2, 0, 1, 0. Okay. So this is 2, this is 6. Okay, this is 2, this is 6, and also this is 2. Okay, so now what we have to do is we need to convert into hexadecimal. Hexadecimal ki convert, octal to hexadecimal convert cheyalante first మనం ఏం చేయాలి అని అంటే we have to convert into binary. Okay, we have to convert into binary. Put 0 1 0 0 1 sorry 0 1 0 1 1 0 1 0 here 110 110 and after point 010. ఇక్కడ ఏం చేయాలి దీన్ని what to convert into, this is binary conversion. Okay, this is binary conversion. To make it to hexa, what you need to do, you need to add one more bit. Okay, so ఇక్కడ ఏం చేస్తారు 011 010 కదా. So we to make it as a group of 4, what you have to do 1 2 3 4. Okay, ఇది 4 కలిసి ఒక group అయినాయి. 0 1 you need to append 0 0. Okay, so 0 0 0 1 is 1 and here 0 1 1 0 is 6 and 0 1 0 0 is 4. Okay, 1 6 4 is nothing but hexa conversion. Okay, octal to hexadecimal convert cheyali అని అంటే uh, you have to convert octal number to binary and then you have to convert the binary to hexa. Okay, so next one is I will give you one small, మీకు అర్థమవుతుందా లేదా అని ఒక చిన్న క్వశ్చన్ ఇస్తాను, you just solve it. Here only I will write. So can you convert this one 1101 01 110101 point 1010 10. Okay, so this is in binary. Okay, this is in binary. Convert to octal. Okay, so quickly someone tell me the answer. So this is the question. So quickly convert to octal and tell me the answer. 65.52. Very good, Prashant. Okay, so ఇంకొకటి చెప్తాను చూడండి. Prashant, now you keep quiet. So for others you have to tell me 0. Yes, Ganesh, you also keep quiet. Now you both told the answers, right? So now 10 10 11 11 0 1 point 011 1. Okay, this is binary. Quickly convert into octal. Ganesh and Prashant, you just be silent. Others who are there in this meeting, I want Ashok and Narayana, I want answers from you. Quickly you convert and tell me. Quickly. It will not take so much of time. Just group into 3 3. టైప్ చేయండి, అక్కడ పింగ్ చేయండి సరిపోతుంది. Okay, and see, no, I did not get any answer from the other two. Okay, That's okay. Prashant and Ganesh, can you tell me? Narayana, very good, very good. Okay, 2575.34. Very good, very good. Okay. So now I will see uh, 40. Yes, 40. Check with your answer once. Now I am giving 4057.06. Okay, so this is the octal number. Now convert this into decimal. Convert this into decimal. Okay, good, Ashok. So thank you for the responses. Okay, so 4057.06. Okay, this is the octal number. Okay, this is octal. Okay, but 116.4 etla ఇది what is that 226.2 is octal కదా. దీన్ని నేను ఏమంటున్నాను, కన్వర్ట్ ఇంటూ డెసిమల్. హౌ డు యూ కన్వర్ట్? You need to convert into binary. What you can convert directly, no need to convert into binary and then to decimal, no need to go like that. Okay, similarly you can directly convert into decimal. Ela convert chestaru? Yesterday we have seen 4 into 8 power 3 plus 0 into 8 square. Will you do it? Tell me the answer. I just given you the hint. Just tell me the answer. Four into 8 power 3 plus 0 into 8 square, 5 into 8 power 1, 7 into 8 power 0. Okay, point tarvata entidi 0 into 8 power minus 1 plus 6 into 8 power minus 2. Finally, what you are getting? Four zero five 4057.06. I told you to convert into decimal. నేను ఒక hint కూడా ఇక్కడ మీకు చెప్పాను నిన్న. ఇది decimal to binary conversion. Binary to number is given. What is the answer? 2088.25. So you need to check the 251 point. No. Or else, if you don't know, you can convert to binary, and from binary you can convert to base 10. Okay. So one more thing will go, and then one more question I will give you. చూడండి, octal and hexadecimal. Octal to hexadecimal conversions. Conversions are very important. Okay. So నేను ఇంకొకటి చెప్తాను చూడండి. 378.93. Okay. So base 10. Base 10 is representing what? This is decimal. Okay. So convert to octal. Okay. Convert to octal. What is the octal? What is the octal equivalent for this? 378.93. ఇది ఏం లేదు, డైరెక్ట్ గా బైనరీ వాల్యూస్ రాసి బైనరీ టు ఆక్టల్ యూ కెన్ కన్వర్ట్. octal. This is decimal, base 10. You can convert into binary. Binary nundi you can make 3 bits as group, and you can tell me the octal equivalent. లేదంటే you can take 378. Okay, so 8 toti every time you divide and you write the what 572 is only for, but 572 point something will be there. Okay, for this 0.93 you have not done anything. 0.93 కి ఏం చేస్తారంటే 0.93 కి into 8, and whatever the x you are getting, and this x again into 8, y you are getting y again into 8. Okay, so z whatever you are getting z into 8, like that you do. Okay, this is the second method, or else easiest way is you have to convert into binary, and from binary to octal. Okay, it is easy to convert. Okay, you try, and okay, let's not waste the time. These are you try slowly. Okay, you try slowly. So we'll go to complements. Okay, so complements. So why, what is the use of complements? Complement is nothing but if a is sorry, if 0 is the bit, okay, the complement of 0 is 1. So 1 is the bit, the complement is equal to 0. Complementing is nothing but inverting. Okay, complementing is nothing but inverting. So why do we need to invert? See, digital addition is very easy. Okay, digital addition is very easy. 1 0 0 1 0 1, sorry, 1 0 1 1 0 1 0 0 1 1 1 0. Addition is very easy, but when it comes to subtraction, okay, again it will be a big headache. Okay, so and also, so to make the subtraction very simple and easy, we can go for complementing. Okay, we can use the complements. So to only for to simplify the subtraction, we can go for complements. And for logical manipulation also, is especially what in encryption also we use the complements. And simplifying the any operation, it leads to less expensive circuits. So binary subtraction is by subtractor circuit is difficult to design. Okay, it is difficult to design. Complexity is more for the subtractor circuit. But whereas you take the adder circuit, so it is easy to design with simple and or nor XOR gates. We can easily design the adder circuit. Okay. So to make very simple, we can go for the complex. To make the subtraction simple, we can go for the complementing procedure. So we have two types of complements for each base R system. Okay, so first one is diminished radix complement, and sixth one is second one is the radix complement. Okay, diminished radix complement and the radix complement. So we will see what is diminished radix complement. So, or it is called as R minus 1's complement. Now if a number is given, okay, it may be a number n. So the base is R. Okay, base or radix. Okay, it is R, and number of digits are n number of digits. So R minus 1's complement and a diminished radix complement. So actually R is the radix. Now we are diminishing the radix. Okay, so you are adding minus 1 to 3. Diminished radix complement, it is defined as R power n minus 1. Let us suppose 1 0 1 0. Okay, so this is the digit actually. N is the digit which is 1 0 1 0. What is the equivalent of 1 0 1 0? What is the equivalent of 1 0 1 0? Hmm. 10 is the equivalent of 1010. So how do you give the diminished radix and how many bits are there? 4 digits are there. Okay, 4 digits are there. So diminished radix complement can be given as what is the base here? Binary base is 2. Okay, 2 power 4 minus 1 is nothing but the diminished radix complement. And similarly, example if you take, here is the example. Okay. So example for 6-digit decimal numbers ఉన్నాయి కదా, ninth complement can be given as r power n minus 1, r power n minus 1 minus capital N. You know r is radix, n is number of digits, and the capital N is nothing but the digit. Okay. So 10 power 6 minus 1 minus n. So 10 power 6 minus 1 is nothing but 999999. So minus n. Okay, minus n. This n is nothing but any number. So let us suppose if we are taking n is equal to 546700. N is equal to, if n is 546700. So diminished radix complement can be given as what? 999999 minus 546700, which is equal to this one. Okay. So let us anything. Okay, if n is equal to, if you are taking 64568 9. So what is the diminished radix complement? So r power n minus 1. R power n minus 1 ante, okay, 9999 minus 64568 9. What is you are getting? You write. That's it. Okay. Nothing much about this one. Next one. Let us suppose if you take a decimal number, r is equal to 10, and now the radix is equal to 10. Now diminished radix complement ante r minus 1 we have to take, which is equal to 9. Okay. So this is called as 9's complement of n. So which is equal to 10 power n minus 1 minus n. So this minus n may be anything. So 10 power n, it represents a number that consists of single 1 followed by n number of zeros. Okay, n number of zeros. Okay, n ante malli here don't get confused. N is equal to number of digits. Okay, n is equal to number of digits. 10 power n minus 1 is a number represented by n nines. So for r is equal to 2, binary numbers radix will be equal to 2 for binary number 1010. This binary number radix will be equal to 2. Decimal number and decimal numbers are represented 0 to 9. So 0 to 9 ante anything. Okay, 45 decimal number aithe. So radix 10. Okay. So diminished radix constant will be what? 10 power n minus 1 minus ante ikkada entidi 10 power n ante 2 decimal places are there, right? 100 minus 45. Okay. In the same way, for binary numbers, r is equal to, for binary numbers r is equal to 2. R minus 1 is nothing but 1. This is called 1's complement. Okay. R minus 1, you are not adding any power. 2 power n, 2 power n minus 1 minus n. This is diminished radix constant. 2 power n is representing binary number that consists of 1 followed by n number of zeros. Okay. So this is all the theory part. Now you see here. సో కాంప్లిమెంట్ ఇప్పుడు అదేమంటారు 000011. సో 2 power 4 minus 1 minus 0011. So this one we need to perform. If you want to perform this particular subtraction, what we need to do is first in the form of complement. Normally ఏంటంటే directly you can take 2 power 4. 2 power 4 is nothing but what? 2 power 4 is 16. 16 minus 1 is equal to 15. Okay, 15 minus 0011. Okay, so you can convert either that into binary or you can convert this into decimal and you can perform the subtraction. But we are going for complement form. ఓకే చూడండి. సో 2 power 4 minus 1 minus 0 0 1 1. దీనికి ఏం చేస్తున్నామంటే వీఆర్ జస్ట్ finding out diminished radix complement. ఓకే సో ఎలా ఫైండ్ అవుట్ చేయాలి అని అంటే సో 2 power 4 is nothing but so 2 power 4 first మనం ఏం రాసుకుంటాం 2 power 4 in terms of binary if we are writing it will be what is 2 power 4 2 power 4 is equal to 16. Okay so 16 this is the binary equivalent of 16. Okay so one's complement first what you are doing so you are subtracting 1 1 తో subtract చేసినప్పుడు you are subtracting 1 1 subtract చేసినప్పుడు దీనికి you are getting 0 1 1 1 1 so whatever 0 1 1 1 1 so 1 1 1 1 నుండి మళ్ళీ again whatever the digit n is there this is n so this is n this digit you are subtracting. Okay 1 minus 1 0 1 minus 1 0 1 minus 0 is 1 1 minus 0 is 1. Okay so finally you are getting this one. Is there any confusion or are you able to follow? ఏమన్నా కన్ఫ్యూజ్ చేస్తున్నానా నేను or is it easy for you to follow? Shall I go ahead? Yes, this is one's complement only. Okay, this is one's complement only. Okay, one's complement lone. So we are just looking at diminished radix complement. Okay, diminished radix complement. So దీంట్లో if we are taking an example to 2 power 4 minus 1. Okay 2 power 4 minus 1 minus 0 0 1 1 నార్మల్గా దీని వాల్యూ ఎంత చెప్పండి 2 power 4 minus 1 అంటే it is 15. Okay 15 minus 0 1 0 0 1 1 అంటే ఏంటి 0 0 1 1 అంటే ఏంటి 3. Okay 15 minus 3 is equal to okay 12. So now if you see 0 1 1 0 0 ఇది 12 కదా okay 12. So normally directly one thing is normally directly if you are performing the subtraction like this 2 power 4 minus 1 minus the equivalent of 15 sorry equivalent of 3 you are taking 0 0 1 1 ki 3 kada so you will get 12. Okay but the thing is we are following this complement procedure direct ga this thing is the main intention behind this is to reduce the hardware circuitry. Okay only reason is to reduce the hardware circuitry. Okay here what we are doing 2 power 4 minus 1 ని మనం ఏంటిది బైనరీ లో కన్వర్ట్ చేస్తున్నాము. Okay this is 16 2 power 4. So what is this first ఏం చేస్తున్నాం -1 తోటి we are just complementing. Okay so this is the complement. Okay మీరు సబ్స్ట్రాక్ట్ చేసినా అంతే వస్తుంది 0 so 0 1 1 1 1 so inverse complement చేసిన తర్వాత so what is the value which are last will this one we can discard. Okay so 1 1 1 1 ki what you are doing you are taking this value which is nothing but 3 దీన్ని మీరు సబ్స్ట్రాక్ట్ చేస్తున్నారు. Okay so this way you can perform the subtraction using one's complement. next one is complements for 7-digit binary number. So once we will be using that radix method only. So 7-digit binary number. So okay, we will take what is this? 2 power 7 minus 1 minus n kada. Okay. R here R power n minus 1 minus n. Okay. So n is nothing but a binary number. So 2 power 7. So let us take, if we are taking this one 1011 triple 0. If we are taking, so what is the ones complement? ఇప్పుడు దీనికి ones complement, this is n. Okay, దీనికి ones complement తీసుకోవాలి అని అంటే what we have to do is so all ones minus 10 minus this number. So what you are getting is 0100 triple 1. So here what do you observe is if you are taking if you are subtracting from r power n minus 1, so it doesn't require a borrow. Okay, so here the diminished radix complement can be computed digit by digit for 7-bit binary number. దీనికి ఇంకొక ఎగ్జాంపుల్ చెప్తాను. Let's see. So see here what you are doing is 1011 triple 0. Okay, so this is 7-bit. Okay, 7-bit binary number. So what you are doing, you are just complementing. Complement చేసినప్పుడు this is ones complement. Okay, ones complement. If you are ఈ ones complement చేసిన తర్వాత what you 0 will become 1, 0 inverse 1, 0 complement 1, 0 1. This is the ones complement. Okay, so then what you need to do, ones complement చేసిన తర్వాత you have to add these two. When you are adding, what happens? You are getting all ones. Okay, so this is the ones complement of 7-bit binary number. Okay, 7-bit binary number. Okay, so next one is second one is first one is diminished radix complement. What we have discussed it now. Now this is radix complement of, or it is called as adi mundu ఏంటిదనంటే r minus 1. Okay, so mundu ఏంటిదంటే r minus 1, r power n minus 1 we have taken, right, minus n. So what we have done, whatever the number is, just we are complementing. First complement చేస్తున్నాము. Okay, complement చేసి and then you are what adding. Okay, complement చేసి add చేస్తున్నాము. Okay, so that is what. But here in radix complement or r's complement, so what you are doing, number is n, base is r, and n number of digits. It is defined as r power n minus n for n not equal to 0, and it will be equal to 0 for n is equal to 0. Okay, so r's complement is obtained by adding 1 to r minus 1's complement. So we can write r, why? Because r power n minus 1 minus n plus minus n plus 1. So if you are expanding this one, what you will get, r power n minus 1. Okay, so ఇదేంటిది అని అంటే diminished radix constant. Okay, minus n and plus 1. Okay, ఈ plus 1 minus 1 cancel అవుతే r power n minus 1. This is what is called as radix complement. So here if we see the tens complement ante you need to you should leave all the LSBs. Okay, so least significance anni least significant zeros should be unchanged by subtracting first non-zero least significant by digit 10. సో ఇవన్నీ వాట్ ఈస్ దిస్ ఆల్ దీస్ థింగ్స్ ఇది చూస్తేనే అర్థమవుతుంది. దిస్ థియరీ పార్ట్ వీ కెన్ rules. Okay, just we will understand by this. So this is r power n minus 1 kada, r power n minus 1 na n, r power n minus n. Okay, capital N. Okay. So here we will write n is number of digits. Okay, so n is the number, n is the number. So r is the base or it is the radix. Base 10, if you are taking the example of base 10 number, so the tens complement of, we are taking 0, 1, 2, 3, 9, 8 is the decimal number. Okay, decimal number. దీనికి టెన్స్ కాంప్లిమెంట్ ఎలా తీసుకోవాలి అంటే, హౌ డు యూ టేక్ ద టెన్స్ కాంప్లిమెంట్? సో యూ విల్ ఆర్ పవర్ అంటే హౌ మెనీ పొజిషన్స్ ఆర్ దేర్, 1 2 1, how many digits are there? 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. So that's why 6 kada అంటే r power n minus n you have to take. Okay, r power n is nothing but what? R power n is nothing but r power, what is n? Number of digits kada. How many number of digits are there? 6 minus what is the digit, what is the number actually? Minus 0 1 2 3 9 8. Okay, 0 1 2 3 9 8. So what we are doing here, 9 9 9 9 9, and here we are taking 1 0. Okay, so here also what you are getting here, you are getting this is okay. So if you are taking 0 1 2 3 9 8, so what are you doing here? What are you doing here? Can you tell me? How many, what is n, what is capital N, and what is R? N is equal to 6. So one point you see here, you need to subtract. Yes, good. So you need to subtract first non-zero LSB digit by 10. Okay, so this is one important thing. Subtract non-zero least significant digit by 10, and by subtracting all higher significant digits from 9. Okay, so see here, 0 1, this is the number 0 1 2 3 9 8. Okay, so all, what is the least significant bit? 8. Okay, this is the least significant bit. This least significant bit, what we are doing, we need to subtract by, if it is non-zero only. Okay, so 8 is a non-zero, it is a non-zero. Okay, non-zero LSB. If it is non-zero LSB, you need to subtract by 10. Okay, you need to subtract by 10. So what you have to do is 10 minus 8 is 2, 9 minus 9. So finally what you are getting is this much. Okay, so now 2, we will take one more thing, 2 4 6 7 0. Okay, 2 4 6 7 0. So here first, what is here, what is the first least significant bit, you tell me? ఇక్కడ చూడండి 2 4 6 7 0 ఉంది కదా. సో see here 1 2 3 4. Okay, 1 2 3 4, 0 ఉంది కాబట్టి you just put it 0. 0 ఉంది, you put it 0. So 7 is the first 7 is the first non-zero LSB. Okay, 7 is considered as first non-zero LSB. అందుకే 7 ని మీరు ఏం చేస్తారు అని అంటే you need to subtract by 10. Okay, so zeros ఉంటే you just put zeros. Zeros నుండి whatever is the first LSB you need to subtract it with 10. Okay, then you will get either minus cheste what you will get 3, 9 minus 6 3, 9 minus 4 5, 9 minus 2 7. Okay, so నేను ఇప్పుడు ఇంకోటి ఇస్తాను చూడండి మీకు, you do it. Okay, so you do it. What you have to do, 2 4 6 3 8 0 0. Now find the complement of this one, tens complement of this one, this number. Find the tens complement. Okay, 7 నేను రాస్తాను అగండి. What is it? 7 5 okay. So 2 4 6 2 4 6 3 8 00 కదా. What we have, what is the in this 7 5 3 6 2 00, 7 5 3 6 2 00. Here what is the least significant non-zero bit? 2 4 6 3 8 00. Yes, least yeah, 2 4 6 3 8 00 lo 8 is the 8 is called as the LSB, non-zero LSB. Okay, 0 0 ki you just use 0 and 0. 8 ki matram you need to subtract with 10, and all others 9 9 9 and 9. Finally what you will get 0 0, and 10 minus 8 is 2, 9 minus 3 is 6 3 5, and what you will get 9 minus 2 is 7. Like this you have to do. Okay, so this is tens complement. This is what is called as tens complement. Okay, so next one, tens complement. Two's complement. Okay, two's complement is also called as radix complement. Okay, two's complement is also called as radix complement. Two's complement is very simple. Okay, so we need to take one's complement ki plus 1 add chesta. Take one's complement and then add 1. Okay, take one's complement and then add 1. So next step, toggle all the bits to the left of the first one from the right. Okay, first one from the right. If you see this number 1011 000, so if you are taking the ones complement, if you are taking, this is the number 1011 0000. So now if you are taking the ones complement, okay, just ignore this one. If you are taking the ones complement of this one, 1 becomes 0, 0 becomes 1, 1 becomes 0, 1 becomes 0, 0 becomes 1, 0 becomes 1, 0 becomes 1, and 0 is becoming 1. So now what you need to do, simply add change. 0 plus 1 is equal to చూడండి 0 plus 1 is equal 0 plus 1 0. Okay, so sorry, 0 plus 1, this is
1 plus 1 madam.
yeah 1 plus 1 is 0. Okay, and here 1 plus 1 is 0, 1 plus 1 is 0, 1 plus 1 is 0, 1 plus 0 is 1. Okay, so simply 0 1 and 0, or else what you need to do, okay, just simple ga meer em chestaru anante you can simply put it like this. Okay, what this number you take, so if you take the ones complement, it will be 0 1 0 1 0 0 0 0. This is two's complement. Sorry, this is two's complement. So complement and then add 1. That's it. One more thing is, I will give you one more question here. So దీనికి 0 1 0 1 0 1. Find out the 2's complement, what you will get. ఫస్ట్ ఏం చేస్తారు, మీ 2's complement కి జస్ట్ కాంప్లిమెంట్. ఏం కాంప్లిమెంట్ చేస్తే ఏమొస్తుంది, 1 0 1 0 1 0 you will get. Okay, this is the complement. Then add 1. Okay, if you are adding 1, what you will get? If you are adding 1, this is 2's sorry, this is 1. Okay, if you are adding 1, 0 1 1. Okay, 1 0 1 0 1. So if you are adding 1, you will get this one. Okay. Next one is, if it is base 2, okay, complement 2's complement of 1 1 0 1 1 0 0. Okay, so what you need to do, ఇది ఏంటిది, ఇదేమో నంబర్. ఓకే, this is the complement. This is the complement. For this complement, if you are adding 1, you are getting the result like this. Okay, you are getting the result. Okay, for this number, 2's complement is this one. Next one is, what we are, that we have done till here. So this one is also same, base 2 ఉన్న number, 2's complement. So next one, now complement of the complement. Okay, what is, ఇప్పుడు let us suppose, so A is a number. Okay, A is, let us suppose it is any number. So the complement of A is A dash. If you are giving complement of the complement, it will be A only. Okay, it will be A only. Okay, just 1 second. Okay, so when you are this is called the complement of the complement. Okay, when you are when you are finding the complement of the complement, it will restore back the original value. Okay, it will restore back the original value. That is the use of complement of the complement. So R's complement, so here R's complement of n is nothing but R power n minus 1. So the complement of complement will give you R power n minus R power n minus n. So R power n and that minus of R power n will get cancelled. So n will be the original number. Okay, original number. A simple thing. You can 0 complement is 1 and 1 complement is 0. 0 is restored back here. Okay, that is the use of complement of the complement. Okay, so see here, this is one example for the complement of the complement. So m is 72532, n is 3250. Now what you are taking, 10's complement. 10's complement ante, so here this is the LSB. LSB should be subtracted by 10, others should be 9. Okay, so 10 minus, this is 96750. The result which you are getting is 96750. Okay, 96750. So this is step 1. Okay, first is taking the tens complement of n. In the second step, what are you doing is to find the sum, you need to add the tens complement of n to n. So మనకు వచ్చిన రిజల్ట్ ఏంటిదంటే 7 చూడండి ఇక్కడ 7 96750. It is a tens complement you are taking. Second step, what you are doing is to this 96750 you are adding 2m. Okay, you are adding to m 72532. So this is m and this is the tens complement of n, complement of n. So to find the answer, what you need to do, you need to discard end carry of 10 power 5, subtract r power n from sum. So what if you are adding these two, you are getting 169282 to this 169282. So what you need to do, you need to subtract with 10000. So answer is 69282 you will get. Okay, subtract r per n from sum. Okay, simple thing. Once again I will tell you, and we will take one more example on this. So what we are doing is taking complement of the complement. Okay, taking complement of the complement. So finally, using what you are doing, you are taking one in the first step, you are taking n. Okay, so you are taking the tens complement 27468 you are getting after tens complement. So to find the sum, what you need to do, you need to add a tens complement of n to m. ఇదే ఎగ్జాంపుల్ నేను చూపించింది. Okay, m and n are there, right? Okay, tens complement of n you need to take. So 96750 you got. So in 96750 ki what you are doing, you are adding the value of m. Okay, so m plus tens complement, ఇక్కడ సింపుల్ గా గుర్తుకు పెట్టుకోండి, m plus tens complement of n. Okay, so whatever the sum you are getting, so you need to subtract whatever the sum you are getting, you need to subtract with 100000. So finally what you are getting, 6969282. Okay, so this is what. One more I will show you. So m is 3250, n is 72532. So now using tens complement, question is using tens complement, subtract 3250 minus 72532. So tens complement of n we need to take, which is nothing but 27468. Okay, so tens complement తీసుకున్న తర్వాత second step tens complement ki, so this is tens complement of and this is the m value. Okay, if you are adding, summing up, you are getting 30718. దీనికి final గా to find the answer, take minus tens complement of the sum. Okay, so to this 30718, again what you need to do, you should take the minus tens complement of sum. Finally you are getting this thing. So ఇక్కడ ఏంటిదనంటే మీకు చూడండి, answer 3250 is the small number and 72532 is the large number. So whatever the result which you are getting, you should get in, okay, you should get in minus. Okay, it should be minus 69282. So మీరు అలా ఏమంటారు ఫ్రమ్ స్మాల్ నంబర్ ఇఫ్ you should subtract the biggest number, what you need to do again, you have to follow this procedure 9999, and this is the LSP, right? For the LSP you need to add 10. So whereas in the first case, if you see in the first example, if you see, this is the smallest number and this is the biggest number. For that what you need to do is subtract with, you have to subtract with r power n. Okay, this is nothing but r power n. R ante entidi, what is r? R is nothing but the radix. Okay, n is nothing but number of digits in the number. Okay, so r power, subtract r power n from the sum. Any confusion here? Any confusion here? So in simple subtraction. Okay. So if you don't have any confusion, you subtract 3, 5, 4, 8 minus 2, 6, 9, 3. Okay. So this is your M and this is your N. Okay. First step, what you need to do? Step 1 lo em cheyali cheppandi. In step 1, what you need to do? Take the tens complement. Tens complement of N is equal to what? 2693 kada. What is the tens complement of 2693? Quickly. Hint ఇస్తాను చూడండి. టెన్స్ కాంప్లిమెంట్ ఆఫ్ 2693. టెన్స్ కాంప్లిమెంట్ ఫైండ్ అవుట్ చేయాలి. యా 7307. ఏం చేస్తారు ఇక్కడ? 9 9 9 10 2693. ఓకే, అంతే కదా. 10 minus 3 will be equal to 7. 9 minus 9 0. 9 minus 6 3. 7307. సో ఈ 7307 కి మనం ఏం యాడ్ చేయాలి చెప్పండి? 7307. వాట్ యు నీడ్ టు డూ? వాట్ ఈస్ ద సెకండ్ స్టెప్ టు దిస్ 7307? యు నీడ్ టు యాడ్ m కదా. సో వాట్ ఈస్ m? 3 4 5 8. This is n. When you are adding this to, what is the result you are getting? What is the result you are getting? 5 6 7. Yeah, 1 0.
3548 madam.
3548. I'm sorry. సరే, ఏదో ఒకటిలే. 3548 ఇక్కడ మీకు ఏమొస్తుంది? 10865 వస్తుంది. ఏమొచ్చింది? ఇది దీని సమ్ ఏంటి? 35487307. What is the result you are getting?
10855.
10855. So now we 10855 కి ఏం చేయాలి? What you need to do? 10855 దీనికి what you need to do? If you are subtracting, this is the biggest number, this is the smallest number. మీకు రిజల్ట్ సైన్డ్ రిజల్ట్ వస్తుందా, అన్సైన్డ్ రిజల్ట్ వస్తుందా? -3548 -2693 సైన్డ్ వస్తుందా, అన్సైన్డ్ వస్తుందా? అన్సైన్డ్ వస్తుంది. సో వాట్ యూ నీడ్ టు డూ? యా 10855 కి వాట్ యూ హ్యావ్ టు డూ? అగైన్ యూ నీడ్ టు టేక్ 9 9 9 9 and LSB is 10. Okay, so finally what you are getting? Tell me the result. 89145. చూడండి whether I'm wrong or correct. 89145. So next, see, to just after the class, I will share this PPT with you. You can go through this PPT and see. Just in 5 minutes, you will see the overview. That's it. Why? Because you should not have any doubts after the class. So conversions yesterday we have seen, and today in today's class what we have discussed, octal to hexadecimal conversion. Octal to hexadecimal conversion is, so whatever you need, octal means grouping in three. Okay, grouping in three. You should append with zeros and then you should group to four. Then your number will become hexadecimal number. Okay. So చూడండి, this is the example for octal to hexadecimal. ఈ octal number కి డెసిమల్ పాయింట్ తర్వాత అయితే రైట్ సైడ్ జీరోస్ అపెండ్ చేయాలి. ఇటు సైడ్ డెసిమల్ పాయింట్ కి లెఫ్ట్ సైడ్ అయితే యూ హ్యావ్ టు అపెండ్ ద జీరోస్ హియర్. సో యూ నీడ్ టు మేక్ అ గ్రూప్ ఆఫ్ ఫోర్, దెన్ యూ దిస్ what binary number. Okay, octal to binary and binary to hexa, that's it. Okay, so octal, this is octal and hexadecimal. Now complements ఎందుకు యూజ్ చేస్తారంటే టు సింప్లిఫై ది ఆపరేషన్ and also to reduce the logic circuitry we will be using the complements. The complements లో టూ టైప్స్ ఉన్నాయి, diminished radix complement ఒకటి, radix complement. diminished అంటే diminish అయిపోతుంది, అంటే R-1 యాడ్ చేస్తారు, దట్ ఈస్ కాల్డ్ as diminished radix complement. అండ్ diminished radix complement లో for decimal numbers r is equal to 10, and you can do either for decimal numbers or binary numbers or octal numbers, whatever it may be. You can do the diminished, you can find out the diminished radix complement. So it will be like this. Example ఏంటిదనంటే, if you are taking 0 0 1 1, so it will be 2 power 4 will be equal to 1. You are writing the binary and then just you are subtracting. Okay, then you are subtracting, that's it. Okay, so taking the complement and then subtracting. So if you are taking 7-digit binary number, what you are doing, so it will be 7 digits. Okay, minus n. So see here, ones complement you need to take, and after taking the ones complement you need to subtract. Okay, so these are the examples. So 7-bit binary number taking the ones complement, so whatever the result, that will be your complement. So and normally this is diminished radix complement. Radix complement lo entidi anante, so it is just r power n minus n. Okay, so but in radix complement what you need to do, first LSB you need to subtract by 10, others you need to subtract by 9. Okay, so see here, this is the example. See, whatever the LSB is there, if it is non-zero LSB only, you should take 10. If it is a 0, if LSB is 0, simply put 0. Where the non-zero LSB is starting from, there you need to put 10. You need to start with 10 followed by 9s. Okay, so these are 2's complements. We have 2's complements ante, you first whatever the binary number is there, you do the ones complement and then you add 1, that is nothing but your 2's complement. Okay, so this is the number, this is the ones complement, to this ones complement you are adding 1, the result is nothing but the 2's complement. Okay, so see here, these are the examples for 2's complement. What is the use of, now next one is complement of the complement. Complement of the complement will give you the original value back. Okay, so this is about the complements. So these are some rules actually. Okay, these are the rules you can go through. చూడండి, ఇక్కడ subtraction of 2 n-digit unsigned numbers n-1 in base r can be done as follows. So add the minuend m to the r's complement to the subtrahend n. Okay, so these are all the rules. If m is greater than n, if m is less than n, ఇవన్నీ కూడా నేను దీనిలో చూపించేసాను మీకు. m is greater than n కాబట్టి, so what you need to do, first step, take the tens complement of n. Second step is adding the value, the result to m, and then as ఈ కండిషన్ కాబట్టి condition m is greater than n కాబట్టి simply what you need to do is, so whatever ఈ రిజల్ట్ కి 10000 it. Okay, so for this particular ఇక్కడ ఏంటిది అని అంటే 3250 minus 72532, ఇక్కడ m is less than n. సో ఈ కండిషన్ లో మీరు ఏం చేస్తున్నారంటే m is less than n లో, so what you are doing, you are taking same thing you are performing. Finally what you are doing, you are subtracting with 9999, same tens complement ఉంది కదా, so same thing you are following. Okay, so we'll discuss the rest of the things tomorrow. Today's class is clear, right? So I will share this PPT with you. We'll share this PPT with you. If you are stuck anywhere, or if you still have any doubt, you can always ask me in the class, or you can ping me personally. I will tell you. And
మ్యామ్
చెప్పండి.
ఇప్పుడు టెన్స్ ఈ సబ్ట్రాక్షన్ చేసినప్పుడు బిగ్ నెంబర్ నుంచి స్మాల్ నెంబర్ తీసుకున్నప్పుడు మనకి లాస్ట్ 10 ఐ మీన్ టెన్స్ కాంప్లిమెంట్ చేస్తున్నాం కదా మేడం.
అవును.
సో ఇది ఓన్లీ ఫర్ టెన్స్ కాంప్లిమెంట్ అన్నా మేడం, లేదంటే వేరే అదర్ కాంప్లిమెంట్స్ కూడా సేమ్ రూల్స్ అని?
లేదు, ఓన్లీ టెన్స్ కాంప్లిమెంట్ లో.
ఓకే,
ఇప్పుడు టెన్స్ కాంప్లిమెంట్ తర్వాత ఏంటిదంటే టూస్ కాంప్లిమెంట్, తర్వాత వన్స్ కాంప్లిమెంట్ లో అంటే మనకి ఏమి ప్రాబ్లం రాదు. టూస్ కాంప్లిమెంట్ లో జస్ట్ వాట్ వీఆర్ డూయింగ్, వీఆర్ ఇన్వర్టింగ్ అండ్ యాడింగ్ 1. ఓకే, సో టెన్స్ కాంప్లిమెంట్ కి మాత్రమే ఈ రూల్.
ఓకే మేడం.
ఓకేనా, చూడండి, యూ ప్రాక్టీస్. నేను యాక్చువల్లీ నాకు నిన్న టైం లేకుండా నేను అసైన్మెంట్ పంపించలేదు కానీ, సో ఐ విల్ సెండ్ యూ ది అసైన్మెంట్ క్వశ్చన్స్ ఆల్సో. యూ ట్రై టు సాల్వ్ మోర్ అండ్ మోర్. సో కాన్సెప్ట్ అర్థమైతే సరిపోతుంది మీకు. థింక్ యూ ఆర్ క్యాచింగ్ అప్. ఓకే, I will end the session now. We'll share the PPT. Okay, 5 minutes lo share చేస్తాను. You can go through it. Okay, thank you.